Okay, so we're going to start talking about special segments in triangles. You guys are lucky because you don't have to memorize the relationships because we're virtual. So hopefully you keep these notes to the side so you know what to do for these. So first thing we talk about is an angle bisector, is a line, segment, or ray that divides an angle into two congruent parts. So say we have triangle A, B, C, and we have our angle bisector here. Okay, and we're going to label this, let's say D right here. If BD is an angle bisector, okay, so if that's a piece of information you're given, then the only thing that you can say from this diagram now is angle ABD must be congruent to angle CBD. Those two angles are congruent. So I'm putting notes there because you need to remember the type of information that you can conclude from, whatever you're given. So in this case, an angle bisector. Perpendicular bisector, line segment array that is perpendicular to a side and goes through the midpoint of that side. So let's say here, okay, this guy right here, we're going to call this, so we have A, B, C again, and we're going to call this D, E. And so if DE is a perpendicular bisector, okay, there are certain things you can conclude. First thing is, because it's a bisector, you know BE must be congruent to CE. You also can conclude that, of course, DE is perpendicular to BC. Just leave it that way. And you can also conclude that angle DEB and angle CED are right, that all of those angles are right. And next time I'll put a little bit more space. So next thing is an altitude. Oh, you know what, before, I just want to mark that in my diagram, that this right here and this right here, all right, excuse me, are right. Altitude is a line, segment, or ray drawn from a vertex perpendicular to the opposite side or the line that contains the opposite side. So every triangle has three altitudes, three perpendicular bisectors, three angle bisectors, and three medians. This one right here, if I was drawing it from here, this would be essentially the height. So this is A, B, C. I call this D. And so if AD is an altitude, then there's just one or two things that you can conclude. You know that AD is perpendicular to BC because it's perpendicular to the opposite side. You also know angle ADB and angle ADC are right. Okay, so you know that they are both right angles. So I'm just giving you this information so you can look up this vocabulary and kind of remember, okay, this is what I can say from this information. So a median is a line, segment, or ray drawn from the vertex to the midpoint of the opposite side. So if I'm starting here, we have our triangle ABC. If I have my median here, so if AD is a median, then the thing that you can conclude is, of course, BD must be congruent to CD because it's to the midpoint of the opposite side. So what I wanted to show you is these are actually kind of cool and magical with art and whatnot. So I'm just going to show you really quickly the angle bisectors. So here's one angle bisector. And then we have the second angle bisector, and then we have our third angle bisector. What you'll notice is all of the angle bisectors, so it has 3 angles, so I can bisect 3 angles. They all meet at this certain point. This point is called the incenter. And let's see if I can do this. So the incenter is actually equidistant from the sides. So the incenter of your triangle is always going to, what happens is if you drew a circle from this point that's on the inside of your triangle, actually I should have done a much better job of this, you can draw a circle that's what's called inscribed in your triangle, which is interesting for art, but there are other applications. So that was actually first thing I wanted to show you is that the angle bisectors meet at a point called the incenter, which you can create an inscribed circle. The next thing is going to be our perpendicular bisectors. So I'm going to go from A to C, there's 1, C to B, there's 1, and B to A, there's 1. Okay. And with this one, okay, they do, again, miraculously, they all meet in the same spot. When I draw a circle where the center is at the center here, which is the circumcenter, and I pick a point, the radius is, let's say, at C, that's what I picked, it makes a circle that circumscribes, goes around the outside of your figure. So don't want to do that. So I'm just going to show you. You guys see that no matter what, I can make an obtuse triangle, my acute triangle, I can make a right triangle, and it is always, it doesn't matter, the circle, the 3 points on the triangle are always on the circle, and that is with our altitudes, or our perpendicular bisectors. Altitudes are boring, but a perpendicular one. So altitudes, again, here we go. They do meet at one point. There's nothing special here, but they do all meet in one spot. So the 3 altitudes of a triangle all meet in the same spot. And lastly, we have our medians. And our medians do meet in one spot, but I can't actually show you the really neat thing. But basically, if you draw all of the medians of a triangle, so you'd go to the midpoint of each side. So you'd go from the midpoint from A to C, midpoint from C to B, and A to B. And so if I drew a segment, it would be from B to here, C to here, and A to here. Okay. It's actually the center of balance of the triangle, but I can't show you that. But that's called the incenter and is the center of balance. But the only thing I wanted to show you really quickly was that all of them meet at the same spot. So I don't know how relevant this is going to be, but the incenter is the point of concurrency, or that was the centroid. Excuse me. The incenter is a point of concurrency of the angle bisectors. And so it creates a circle on the inside. Point of concurrency of the perpendicular bisectors is the circumcenter, and that's where you have the circle on the outside. The orthocenter is the point of concurrency of the altitudes. And the centroid is actually, this is actually your center of balance, and it's the point of concurrency of the medians. And if we were live in class, it would be a lot more interesting, but I'm going to warn you before, this is just a few more factoids.